find y of x4 for the given first order differential equation dy by dx equal to x square plus y by 2 using modified Euler's method. For the given initial condition, x naught is 1, y naught is 2, h is 0.1. So here we import numpy as np, then we import matplot library as lib dot pyplot as plt. This is for drawing the graph using given values. Now we define the modified Euler's method function modified Euler. So what are the functions we are using and variables we must express here? F comma x naught, y naught, we are using h, and we are using n. Now we give the shape for x, so np dot zeros of n plus 1. So similarly we give the value for shape for y also, np dot zeros of n plus 1. Now x of 0 we give it as, we represent this one as x naught. Similarly y of 0 as y naught. So here for I in a range, so here we give the value up to n. So we write the formula x of I plus 1, it is nothing but x naught, x1, x2. So here we can write it as x of I plus h. So if it is 0 we get x1, if it is 1 we get x2 value. Similarly now k1 equal to h into f of xi comma yi comma y of I. Then k2 equal to h into f of x of I plus 1 comma y of I plus whatever the answer we have got from k1, that should be entered, y of I plus k1. Now we must find out the value of y is nothing but y of I plus 1 equal to, so here we must consider the initial value y naught plus half of, so half can be written as 0.5, otherwise we can write 1 by 2 of k1 and k2, k1 plus k2. Now we print this one, print y of I plus 1. So here we have defined the modified Euler method So we return here, return x and y value. Fine. The function f of x comma y. So return, we type the given function x square plus y by 2. Enter. So we write the initial values. X naught is 1, y naught is 2, h is 0.1. Now for I in range, so here we give 1 to 5. We take at least 4 values for drawing the graph. X and y value equal to modified Euler. So here we have defined the function, then x value, y value, then h, then we write I. Enter. We print this one. So print modified Euler method, solution. So here x we write it as percentage 0.2 float, comma y is percentage, we write it as 1.3 floating values, then percentage, here we give x of I, comma y of I. So we check the output. So for I in the range, numpy has no attribute, zeros. So here we must give so we are getting the output, but here we have given 3 decimal places, so here we are getting 2.216. so here we are getting the value 2.2155 and 2.464 repeatedly, so we might have given the print summer. So here already we have given, we command this one so that it won't execute, and the decimal places we increase, instead of 1.3 as 1.4. now we check the output. See, now we are getting the required values. 1.1 we are getting the output, 1.2, 1.3, 1.4 we are getting the outputs. So here if we want to draw the plotting the diagram, so we give here plt dot grid. So we want show, and we must add some of the things. plt dot show so we must write the x label and y label, x axis and y axis we must mark. So here plotting the curve. So plt dot x label, it is nothing but x. Similarly copy and paste, we do it the same things for y-axis. So y, and if we want to give the title, so we can give plt dot title. So here title is numerical values plotted using the graph. So here we have used the curve dy by dx is x square into y by 2. Check. So we are getting the x values, y values. Here we have given the heading, but we have given the x-axis, y-axis, everything is there. Only thing is a line should be drawn. So here to get the line, so we give here plt dot plot x value and y value, x value as well as y value, in which color you want to execute, that should be given here. Blue color, blue. Then if it is marking, then we give this one. O, we check the output. So we remove this quotation and we check quotation and we check the output. So we have the values, x values. Now you can see that 1 is to 1.1 is 2.215. So here the values are plotted, and we have seen that if the value started from 1, so here we change instead of 1 as 0 and we check. Now you can see here the required value at x is 1, y is 2. Now you can check, we are getting the curve from 1 to 1.4.